Okay, and welcome back for our next lesson on applications 1.1. So again, we've covered area of a triangle, sine rule, and last lesson we looked at the cosine rule, and we're going to finish off our work on the cosine rule today. So we previously had a look at these two formulae. Last lesson we focused on the first formula. Just to remind you again what we're referring to with A, B, and C. The lowercase a, B, and C are just sides of the triangle, and we're using cos A, the capital A, to refer to the angle opposite A. So that's the angle opposite A. In the same way that the capital C is the angle opposite C. Okay, so that's a recap from yesterday. And just to say again, this lesson we're looking at this formula. So it's important to note that these two formulae are the same thing. The one on the right is just been rearranged. So if you could be given this formula and say, be told rearrange it to make cos A the subject of the formula. And you could manipulate that formula from that to get to this. But the good news is in the test, you don't have to do that. They are going to give you both versions of this formula. They're going to give you both, so you can just pick up and use it as you want. Okay, so again, you're given it in the test, and what we're interested in are three sides and an angle. So here's an example. We've been given three sides, and we've been asked to find an angle. If you've been asked to find a side, you're going to refer to the previous video and use the first version of the formula, the one that starts a squared equals. If you're trying to find an angle, you're going to use this version of the formula. Okay? Again, that formula is just straight from the previous slide, and you're given this formula in the test. So I just want to be super clear about that. The other thing to be clear about is this angle A is this angle you're trying to find, and the lowercase a is the side that is opposite it. So this 7 is the side A, this angle is the angle capital A. Doesn't matter which way around we put these now, but B and C are just the other two sides. So that's the really key idea here. The side opposite the angle we know, when we're using the formula, that would be A and capital A. So just to substitute that in, cos A would be cos x, b squared would be 4 squared. In the same way, this is going to be 6.5 squared, that's our c. Minus a squared would be minus 7 squared, divided by 2 times b times c, so that's 2 times 4 times 6.5. And at this point, it is just a case of typing that into our calculator. Okay? So it's going to be 4 squared plus 6.5 squared minus 7 squared times over 2 times 4 times 6.5. And I'd encourage you to do this yourself on your calculator as you watch, because that's going to allow you to check that you're able to input it correctly into your calculator. So you should be getting this exact answer here. And again, we're going to use the inverse cosine function, which we've seen before, to be able to answer this. So we're going to press shift, cos, and that'll type this onto your calculator. Okay, so if you do shift cos, and I would type answer, shift cos answer, and that's going to give you 79.7534319. Okay, so again, make sure that you're able to do that. So if we want to do that to three significant figures, that's going to be 79.8 degrees, which is what we're saying this angle here is. Again, just check that it makes sense. This is clearly smaller than a right angle, so this angle is less than 90 degrees, but it is quite a large angle, so it's a large acute angle, 79.8 degrees makes a lot of sense for that angle there. So it's always worth just checking, does this actually look like it could be, about 80 degrees? And I think we agree that it can. Here's another example. Again, we've been given three sides and we've been asked to find an angle. Again, think of this as angle A and this side A, and then the other two sides are just going to be the sides B and C. Okay, so remember your formula. Cos A is B squared plus C squared minus A squared over 2BC. Again, this is given to you. The hard part really is just correctly labeling this. If you've correctly labeled this, then we've not got a problem. Capital A is going to become X, B squared is going to become 6 squared. Okay? And again, I'm just going to go quiet whilst I type this, but all I'm doing is typing this into a calculator now. Okay, so if you try that yourself, you should be seeing this on your calculator. So that would suggest that cos is equal to, so if you do shift cos on your calculator and hit equals, you should get 75.91145797. And again, this is going to be equal to, we're going to round this to a sensible amount, and that's going to be 75.9 to 3 decimal places. Again, that's degrees. So again, we get the formula, we substitute into it, and then we use our inverse sine function to get to our answer. Now, the way they'll make this harder is they'll perhaps use this as one part in a multi-part question. So take this, for example. You've been asked to find this value here. Okay, so what you need to do is come up with a strategy for finding this angle. Now, there's some things we know. We know that angles on a straight line sum to, do you remember? What do angles on this straight line add up to? 180 degrees. So if we knew what this angle here was, if we knew angle Y, we'd be able to work out angle X. So for example, say this angle here was 80, then X would have to be 100 in order for the two numbers to add up to 180. Okay, so what that tells us is we need to find out Y, and then once we've got Y, we can find out X. So just to say that X is going to be equal to 180 minus Y. Okay, so just check that you're happy with that. But all this down here is saying is that 180 take away Y is equal to X. These two must add up to be 180. And that's a fact that we just need to know, that angles on a straight line make 180. At this point, we've got a standard cosine rule question because what we have is a triangle with three sides and an angle. So we can think of this as angle A, this is side A, this is side B, this is side C. And again, we can use our cosine rule. So I'm just going to write that formula out. Again, you've got this given to you. We're going to substitute, so that's going to be cos Y now. So not cos A, but cos Y. B squared, we're going to say 7 squared plus 4.3 squared minus 7.2 squared over 2 times 7 times 4.3. Again, I'd encourage you to have a go at this. 7 squared. Yeah, so I'm just going to quickly type this in. Okay, so that's going to give you 0.2599667774. So that would be, y is going to be shift cos the answer, and that's going to give you 74.9319096. So what we'll do is, so basically this angle here, y, is about, well, it's about 75 degrees. We'll say 74.9 degrees. Okay, so this actually, yeah, it's 74.9 degrees. So we can work x out by doing 180 minus that 74.9 degrees, and that's going to give us our value of x. So in that case, it's going to be 105.0680908. This is when I've taken away the full thing here. So that's going to be 105.1 degrees. Okay, and so we've got our value of x. Okay, so those are 3 examples. I want you to have a go at the 3 questions on the board now. Again, pause this video and actually stop and have a go at those questions. Okay, so I hope you've done that. I hope you've had a go. Again, question 3 is very similar to the previous question. So we've got 64.6 degrees, 79.5 degrees, and again, for this one, the value of x is 86.7 degrees. Okay, so that's it for this video. You'll have a task to do for the end of the week, and I'll see you next week for some work on bearings.